Ollama promises total privacy, real speed on modest hardware, and a setup so simple it feels like magic. So I put those exact claims to the test against cloud APIs like ChatGPT and Claude. The biggest surprise, the same company selling you local and private now ships cloud models that route your data to its own servers behind a paid pro plan. By the end of this video, you'll know exactly which of Ollama's 5 big promises actually hold up, and which one has a serious asterisk on it. The core pitch is zero data leaving your machine. Community reported packet captures across 3 separate setups showed zero network traffic once the model was downloaded. Local inference never leaves your machine, while cloud services like ChatGPT and Claude retain your data for 30 days after deletion. But there's a catch already baked into the product. Since version 0.12, Ollama offers cloud models, things like Q13 Coder 480b.cloud, that quietly route your request to data center hardware instead of running on your machine. There's no simple toggle to guarantee a strictly offline experience, so the privacy promise is real for local models, but it's no longer universal. That's a clean win for Ollama on the core privacy claim. I dug through official docs, model cards, and community benchmarks, and cross-checked every number against the source that actually reports it. No cherry picking, no vendor money involved. This is where local computing earns its reputation. At 1,000 requests a day, Ollama runs at essentially zero marginal costs, while a cloud API like GPT-4o runs $30 to $45 a month. Community reported. Scale that up to 50,000 requests a day, and the gap turns brutal. Ollama costs you electricity, cloud costs roughly $2,050 a month. The honest catch is upfront hardware. You need $500 to $10,000 plus in gear before that math works in your favor, while cloud needs zero hardware to start. If you already own the machine, Ollama wins decisively. If you don't, that upfront cost is real. Speed is where a lot of skeptics assume local AI falls apart. On a Mac Mini M4 Pro with 24 GB, community reported numbers show an 8B model running around 30 tokens per second and a 13B model around 20 tokens per second, both fast enough for daily work. One of the biggest problems I run into when using AI agents is turning their output into YouTube content I can actually use to market my product. That's why this video is sponsored by Subscriber, a tool that helps business owners connect their AI agents to YouTube and market their products without spending 10 hours every week creating content. You can connect Claude or ChatGPT directly to Subscriber. It then analyzes your business, website, and YouTube channel to help you create SEO-optimized video ideas, scripts, thumbnails, and even complete videos that actually match your brand. What I like most is that every week, Subscriber gives me a list of high-potential video ideas I can immediately execute, and it can even help edit videos for me, with or without my face, including videos like the one you're watching right now. It's easy to get started, and you can try Subscriber for free using the link in the description below. Now back to the video. An RTX 4090 clocks roughly 75 tokens per second on that same 8B model, so dedicated GPU hardware is still 2 to 3 times faster. But that speed costs power. The M4 Pro draws 30 to 40 watts, while an RTX 4090 rig pulls 350 to 450 watts, 10 times more. For anyone running modest hardware, Ollama's numbers are the real story here, not the raw ceiling a 4090 can hit. Stick with me, because the last 4 tests are where this decision actually flips. This is Ollama's clearest, least contested win. One command, Ollama run Llama 3, downloads and starts a model in seconds. Community comparisons put llama.cp at easy, with a compile or binary step taking minutes, and VLLM as harder, requiring a Python environment and 10 plus minutes before your first inference. Direct Llama CPP does run 10 to 20% faster once everything is set up, since Ollama is a wrapper around it with a model registry and an OpenAI compatible API layered on top. But for anyone who just wants to get started, that convenience tax is worth paying. This is the test that complicates everything above it. Since early 2026, some models route to Ollama's own servers instead of running locally, according to community reporting. Ollama Turbo and a 20-a-month Pro plan now offer 50 times more cloud usage, a real monetization shift away from pure local-first computing. Users also report outgoing traffic for update checks, and there's still no simple toggle for a strictly offline mode. This is the one test where the cloud wins, not because the local experience got worse, but because local isn't the guarantee it used to be. Ollama wins privacy with zero network traffic after download versus cloud services that retain your data for 30 days. It wins cost at scale, running on electricity alone versus roughly $2,150 a month for GPT-4o at $50,000 requests a day. It wins speed on modest hardware, hitting 20 to 30 tokens per second on a Mac Mini M4 Pro. It wins ease of setup with a single command versus VLM's Python environment. Here is where the second pick clearly pulls ahead. Ollama wins this review, 4 dimensions to 1. The privacy, cost, and speed advantages aren't marginal. They're the difference between $0 and thousands of dollars a month at scale, and a setup that takes seconds instead of minutes. The one loss, local first positioning, doesn't erase those wins. It just means you have to be deliberate about which models you run. If you stick to local-only models and skip the cloud tier, every core promise still holds. Marketing won't tell you this part. Update checks still generate outgoing traffic even in local mode, so there's no built-in switch that guarantees a fully offline session. And according to community sentiment, some users report painfully slow inference on 24GB max with larger Qwen models, plus disappointing results running agentic coding tasks even on 30 to 120B models. Ollama's ease of use doesn't mean every model performs the way its size suggests. If you want the exact hardware setup that gets you those Mac Mini numbers, that breakdown is coming next, and it's the video to watch before you spend $1 on a rig.